one. Okay, so range calculation. What I'm going to do, guys, is I'm going to take a branch circuits range. I'm going to take a hypothetical situation where we're going to have multiple ranges in fed from one panel, and we're going to size the branch circuit for each one of these ranges, like we do, because we're engineers and designers and master electricians. And we're also going to do the feeder for the whole system. So if you guys look at this table, I want to remind you of very few things. I want to remind you very few things for this table. I know you've seen it. It's not new to you. I want to remind you of a few things. Number one, that you need to be able to do is, this is for residential only, household electric ranges. This is a residential table. So if you're doing non-residential, do not apply this table. Though it also applies for institutional. Institution, if you have an institution and ranges like this table applies to it. Institutional and also residential. Does not apply to McDonald's and Burger King and all those good stuff. Okay, cool. Everybody's okay with that? That's the first thing. It applies for ranges. If you have a range, anybody knows what a range is? Okay, let's define a range: a wall-mounted oven, a counter-mounted cooking unit, or other similar cooking equipment and appliances. Everybody knows what a range is. For most of the time, guys, the range is you're going to have an oven, at least one or two ovens, as well as a counter cooking unit and countertop cooking unit in one big standalone range, right? So we have a unit to cook at the top and one or two ovens in one big appliances. That's your range. Now, so an oven and a cooking unit, that's a range together in one big assembled appliances. Cool. The second thing, then they divide them. If I take the oven, put it in one side, and a cooking unit in another side, that also applies to it. Does that make sense? So cooking unit, ovens, or grab them together and call them a range, that applies to them too. Everybody knows what they're applying to. Cooking units that you cook at, oven you put your turkey in and you roast that baby, or you can put them together and make a range, what we call a range, both of them together. Cool? We know what applies to. The third thing you need to understand is the limit. It has to be over. Look at the word over this number to apply this table to. Over this number. Very interesting. So over. Does that mean if you have a 1 3/4 kW, does this table apply to it? Does it apply to it? No, it doesn't apply to it. It does not apply to it. So that's basically it. And it's a demand factor. It's a demand factor. Any question, guys, about what the table is all about? First, it has to be over 1 3/4 to apply to, and it has the household range or oven or counter cooking unit for residential. So cool. Up to this point, we know what the parameters are. The only thing that also this applies to is you gotta be careful. This is for feeder and service conductors. This table is not for branch circuits unless it tells you otherwise. This table is not for branch circuits unless it tells you otherwise. So very, very important. Can I use this table to size branch circuits? Technically, no. There's one exception. This is for sizing feeders and branch circuits. What a feeder? A feeder between two panels. What's a branch circuit? A branch circuit, can I size this one branch circuit right here? If I want to size a range up to there, can I use this table? Technically, no. You're going to see there's an exception in a second for ranges. So everybody knows it's feeder and branch and service, not branch circuits. No branch circuits unless it tells you otherwise. Okay, so these are the parameters. Let's look at the parameter number one. This table, guys, here's your default. Your default is always under C. You're going to default always to C unless there's an exception that takes you to A or B. To understand this table, always remember, you're always looking at C, always, all the time. So if you guys look at C, it says maximum demand, not over 12 kW, not over 12 kW, not over. Does that cover does C cover A and B situations? Yes, not over 12. So your default, when you default, always you default to C, unless it gives you other alternatives to go to A or B. Cool? What's your default is C, unless you're given alternative to go to A or B. Okay? So that's your default. So for example, if I have 5 ranges, and all my ranges, take this. If I have 5 ranges, let's take just a quick example. I have 5 ranges, and each one of these ranges is 9 kW. 5 of them, 9 kW each. I have to default to where? I have to default to C. So my default is what? 20 kW. Then, Oladipo, my friend, it's not enough. 9 kW, I default to C, that give me 20. Then ask yourself, do I have an alternative to go to A or B? Are they under A or B? Is 9 under A? No. Is it under B? No. So that's the only option you have. This is the most confusing part about this table, guys. Your default is always to C, unless they tell you unless it lies under A or B, then you can apply A and B and choose the one that gives you more demand. Take this. Let's take this one. Any question about this first? I have 9 kW, 20, no problem. 20 kW, done. Why do they do it this way, guys? Highly unlikely that all these 9 kW, the 9 kWs will be running fully at the same time. Take this example, second example. Let's take six of them, right? And let's make this baby 8. Let's make this baby 8 kW. Are you with me? I'm making this 8. I have 6 ranges, 6 of them. Each one of them is 8. What's my default? What's my default? Default. What's my default? 21. What's my default? 21. But what's my default? Always C. Then go ask yourself, can the 8 be under any of these 2 columns, A or B? Can the 8 be under any one of these 3 columns, A or B? Yes, then you have to apply another calculation and choose the one that gets you more demand. Let's do that. So you guys agree with me that 8 is under B, right? So here's 8. Then remember, this is your default. You're defaulted to this. But then you go ask yourself, can I apply another rule to get me more demand? Yes, B. So let's see. B, if you guys do B, it tells you take the 6 of them, multiply them by the 8, and multiply them by the 4 point. This one is actually, I'm going to write 0.48, and that will equal, see what I did? 0.4. Can anybody give me the answer for this? So take the 6 of them, multiply them by 8. So 6 times 8 times 0.43, 21. 20, actually 20 point what? 20.64. 20.64. 20.64. I want you guys to look at this just carefully. So this one gave you 21. This one gave you 20.64. Which one are you going to be using? The smallest number. That's why we default to the smallest number.
The smallest number, not the largest.
The smallest number, yeah. The one that gives you more demand, the smallest number. So look at these two. Which one is the smallest number? Which you guys did it with Gary. I know we did it with Gary with our electrician. Always defaulted to that one. But you see the logic behind it?
Isn't the smallest number less demand rather than more demand?
That's another confusing part. We use this table, guys, to give us a demand, to cut more. The more we cut, the better. So based on this table, the better solution for us is the more demand, meaning the smaller number, meaning the smaller. It's
Wait, if I have a demand of 40 kVA,
yep.
Or I have a demand of 20 kVA,
Yes.
which is the greater demand?
20, which is better demand, not greater.
No, I said you're using the term greater.
Yeah, which is we pick the best demand, which is a smaller number.
Okay.
The best demand is a smaller number.
Right.
It's not use the greater or what. You do the calculation, guys, and you pick the number, the smallest number. Why? Because that gives me, I don't want to use the word greater, that gives me,
the lowest demand,
yes, use the word the lowest demand.
not the highest
Yes, the lowest demand, the more cut, or the smaller number, Any question about this, guys? Everybody see the default is to C unless it applies to A or B. Let's take another example. Take this one here. Let's take green this time. Let's do this. I have 10 of them. Each one of them, guys, is actually, let's say, less than 3, okay, let's say 3 kW. 3 kW. Okay, Nick, what's your default? For 10 of them, 3 kW. The default, 25. That's your default, 25. Now, hold your horses. Do I have other alternative to apply another rule to it and see if I can get smaller number than this, than 25? Do I? It's under what? It's under A. It's under A, so let's go apply A. Everybody can see that, guys? So in a case like this, then you're going to take the 3, multiply it by how many of them? 10. Multiply it by this number, which is this number, which we, how am I going to say here? Let's just do it 3K. I'm going to do the multiplication right on it here. So I have 10 multiplied by 3K multiplied by 0.49 equal how much? 14.7. Okay, now I want you to look at these two numbers. Which one is the smallest? That one. That's why we default to this number. If you understand this, you would never go wrong with the range calculation, ever. Cool? Can you see that? The default is always you go to where. So in this case, this is my answer. This is my answer. In this case, that was my answer, right? You always default to C, but if there are other rules applied to A and B, then you apply the rule of A and B. Cool?
Defaulting to C just kind of
Pain in the butt.
No, it's kind of also just refresh, kind of help you.
It helps you gauge yourself. So it helps you. So here's C gave me.
Seems like it is.
Yeah.
You obviously know that 3K. Looking at 3K.
Yep.
You know you're not going to go into C.
Absolutely. So if you don't want to default to C, because you know, here's where C becomes defaulted to C becomes very important. The closer you get to 8 3/4, the closer you get to the upper limit of B. The closer you get to the upper limit of B, the more chances that C will give you a higher demand. If you want a hint. We do this with the exam prep, guys. The closer you get, like look here, look at this. This was 8, right? 8K, it's very close to the limit of this column, which is 8 3/4. So we were very close here. We're very close to 21 and 20.6. Now, the further away from the upper limit here, you go this way, the more likely the A and B will give you a smaller number than C, number than C. Any question, guys, about this? Any question? Okay, let's take one more example. Let me take, so we took 9K. I'm going to take the last one example that I'm going to use, as I'm going to take 15. I have 15 ranges. Each one of them is 12K W. What do you think the demand for these babies? 30. What do you think the demand for these babies? 30. Got everybody with me? Right? I have 15 appliances. Each one of them is 12 kW. The demand for these is what? 30. The demand for them is 30. Any question? I'm going to take one more example just to spice it up. I want to take one more example to spice it up. Show you. I have now, if I have, this is interesting. If I have the following size, and I want you guys to look at this one. I have the limit is 1. I have 2.5. Let's put ourselves into right here. I have, under this column, I have 2.5, 11, I have 11, 2.5K. Okay? This is 11 of them. And I have 13 of, let's just say 5K. Cool? I have 11, 2.5K, and 13, 5K. What's my default? They're different sizes now. What's my default? Are they all 12 or less? Are they all 12 or less? Look at all of them. Are they all 12 or less? Yeah, 2.5 and 5. They're all 12 or less. Or less. Or less. How many of the 12 or less do I have? 11 plus 13 is what? 24. 24. If you guys go, I can't go that far. If you go to 24, go to 24 in your book, and what's your demand for 24? Under C. 39. 39. Okay. Listen to me carefully. I have 11 and 12. All of them are under 11 and 13. All of them are under 12. Together, all the appliances less than 12 or less, I have 24. If you go to the table 24, so I'm going to write just because 24 is not here. Here's the demand for 24 under C is what? How much? 39. Okay. Okay. That's how I default to. But remember, Chad, there's another rule. Look at the sizes that do I have. Do these sizes go under A and or B? They do. They go under A and under B, some of them. So you're going to apply that rule. So, okay, let's go to apply that rule then. Here's what you're going to do. The first one is going to be under this one. We're going to take the 11, multiply them by 2.5, multiply them by 0.47. Can anybody give me the answer for that? 11 times 2.5.
27.97.
So 11 times 2.5 times 0.47. What's the answer for that one? 12.9. 12.9. Okay, cool. Are we done? Wishful thinking. We're not. So how about the 5? Where do you guys think the 5 should be under? Which column? The 5 should be under B, right?
There's 13 at 5.
There's 13 of 5. Okay, so the 5 is under B, right? The 5 is under B. So we're going to take the 13, take my 13, because I have 13 of them, multiplied by 5, multiplied by, for 13, what's the demand factor for 13? 0.32, right? 0.32. Okay, give me the answer. 13 times 5 times 0.32. How much? A 20.8K. Cool. Now we're going to add them up and see if do we come up with a number this large or smaller. Okay, let's go add them up. So let's take 12 at 12.9 plus 20.8. What's the answer for this?
33.72.
33.77. Okay. Ashley, do you see now why we use A and B? So for 24 of them, it gave us 39. If we apply the A and B, we got a smaller number, So which one do you think we're going to be using? The smaller number. I can't emphasize the whole rule. We always defaulted to C, guys, but then we apply alternative or exceptions. A and B are exceptions. If the exceptions apply. If it doesn't apply, like in my other situation, well, it didn't apply. So C gave us 39. A and B together, they gave us 33.7. So which one am I going to be using? 33.7 kW.
Why didn't we mess with the 12 kW?
Why don't we mess with the 12 kW? That wasn't part of the example. I'm sorry. I only have these two together for this example. Yeah, the 12 was not part of them.
Oh, okay.
Yeah, the 12 was not part of them. Yeah, the 12 was not part of it. Yeah.
Which it was.
If you,
said that in.
thank you. Good point. What happened if a 12 was with them? then you can apply the 12. I can't apply or A or B, right? I can't. Then what do I need to do? Go directly 12. How much 12 gave us? 30. Add another 30 to that.
So
You're
it's
right on the money.
92.
But then you don't compare them with the 39.
Right.
Yeah,
Got it.
because it's different. Because you can, if you go, here's what you can do. You take the 11 plus 13 plus 15 and see how much that all give you. How many, and then go compare them. Any question, guys, about the default is C, A and B apply as needed. Cool? Okay, now what happened if you guys look at all my calculation were 12 or less? Now what happened if they were more than 12? All my calculation were 12 or less for the KW. Now what happened if it's more than 12? Let's go see what happened if it's more than 12. We know how to handle it if it's 12 or less. What happened if it's more than 12? Cool? Shall we go take a scenario here? I'm going to take a snapshot here and then get rid of all my mess here. Any question, guys, before I move? I covered A and B and C up to if they are 12, up to 12. Now let's go see what if they were not 12? What if they were not 12? Okay, if they're more than 12, I want to guys take you to the note number 1 and note number 2. If you look at note number 1, I'm going to go back directly to the notes now. And then I'm going to go directly to the notes underneath them, right here. I want you guys to look at these notes, very important. Okay, all the stuff that we were doing, guys, was right here. Everything they have done so far, is actually note number 3. Everything that I covered with you so far is note number 3. Now let's go, right? If you read note number 3, it will tell you, oh, by the way, from this to this, you see, except in lieu of C, you can use A or B. That's what in lieu of C. So if A and B apply, please use them and choose the largest. Cool? So we used note number 3 for everything that we've done so far. Let's go look at the other notes. Now what happened? Note number 3, guys, cover you all the way up to 12 kW. Now what happened if you go higher than 12 kW? Here's what you're going to do. Higher than 12 kW, if over 12 kW, all the same size, same rating, over 12 kW, all the same rating, you're going to use C, but you're going to increase 5% for every 1 kW higher than 5% for every kW higher than 12. Does that make sense? I'll take an example for that one in a second. Okay, that's if they were more than 12. Look, number 2. Number 2 says if it's between this number, this is very important. This number here, all the way to this number, different sizes. Add them all up if they're different sizes. Average them. But anything less than 12, make it 12. Average them. Pick under C and increase the average 5% for every kW. The average is more than 5% for every kW. The average is more than 12. You got to read this one, guys. This will tell you, especially where it says maximum demand, and here for any range less than. This is very important, right here. Anything less than 12 and over 3.5, you're going to make it 12 when you apply rule number 2. Okay, and then add them up and increase the demand by 5%. Any question about note number 1 and 2? Very important. You only look at these two if you are more than 12. And also number 2, number 1. Number 2, you look at it if you have a mixture of anything that B does not apply to it and only C. Like look at that, they give you the limit of over 8 3/4. Then you add them up, increase the average 5%. Okay. Any question, guys, about these notes, the first note and the second note? So the last one I want to mention here, we're going to do that one in a second. These two, remember we said institution. You can apply this one to apply. You can apply the same rule to the institutional right here programs. And another thing I want to mention here, my friends, is with green here, is branch circuit. This is a big deal. Branch circuit calculation. Up to everything that we have done so far, this is service and feeders. This is applied for branch circuit. If you read this number 4, everything that I've done so far, this is for feeder and service entrance conductors. How about branch circuits? We're going to do exam branch circuit. For branch circuit, it will tell you if it's a range, it shall be permissible to apply the branch circuit for one range in according to this table. You can size for one range, a branch circuit for one range. If it's a range, you can use this rule, no problem. If it's an oven or a countertop, you have to use the nameplate. Oven, countertop, nameplate. Range, use the table. For branch circuits, cool? Does that make sense? So here's apply this table, and it says if it's oven here, wall-mounted oven or counter-mounted cooking units, you have to use what? The nameplate. Very important, the nameplate. Only the range, one range, you can size it based on the branch circuit based on this table. We'll see that in a second. Only one range. And also they have an exception here. They say if you are an electrician and you decided to group 2 ovens and 1 countertop in one branch circuit, right? How would you do that? You take a branch circuit like here, guys, pull it up to a J box right in here. From the J box, take one tab, no overconnection device. Feed oven 1, another tab oven 2, and a third tab you're going to be feeding a cooking unit, a countertop cooking unit. You can see that? No overconnection device here. The overconnection device is right there. Only this, all of them have to be in the same room. All of them have to be in the same room. If you do that, they allow you to add the nameplate of all of them and treat them as one range and apply this rule. And that, where does that say? Mounted, supplied by branch circuit located in the same area right here. The last sentence will summarize exactly what I was just telling you right in here. Any question about these notes? Any question about these notes? Okay, let's go take the example now. Any question, guys? Okay. So we know how to use this table with the notes. The other thing I would like to mention here about ranges and any question, guys, about this table? Straightforward. One more for branch circuit I want to show you guys. This would be in page related to ranges. That will be household. This will be in page 53 in the NEC code book. Let's go type page 53 here. 53 and enter, Chad. There you go. 53. 53. Yeah, I'm coming. Give me 1 second here. This should be 210.19 A3. 210.19 A3. Is this fifth? You just look at that. 52. Okay, I thought 50. 53. I hope it's 220.8. Yeah, we're right in the money here. We're right in here. Welling units. That 8. We need branch circuits. Branch circuits. Interesting. Okay. Branch circuits is right here. We're going to go to... Okay, so if you guys do me a favor, we're looking at right here. We're looking at branch circuits. You see that? Branch circuits. Branch circuits not over 600. So 210.19A. We're going to go all the way to 3. Right here. To 3. I want you guys to look at this and highlight it. Right in here. Okay, so if you look at this, this is a branch circuit. We're talking about branch circuit for household ranges. This is very important. For ranges over this, the overconnection device must be 40. If you have a range over 8 1/4 or 3/4, 1/4, 3/4, over 8 3/4, your overcapacity device must be, regardless of your calculation, your branch circuit overcapacity device must be 40. So highlight this one. Very important. The second thing I would like to highlight is exception here. This exception is a big deal. When we calculate the neutral for a branch circuit, when you calculate the neutral for the branch circuit, it allows you guys to derate the neutral by 70% for the branch circuit of a range, for the branch circuit of the range. The problem is the demand of the range must of this amount or larger. So if you have a range of this amount or larger, you can actually apply, if you demand range of this amount or larger, you can derate the neutral for a branch circuit. We don't derate neutral for branch circuits. We derate neutral for feeders and services. For feeders and services all the time, the 70% that I gave you guys when we did the load calculation, that was for feeders, branch circuits all the time. We do that for ranges. But for branch circuit, just the wire that's going to the equipment, we don't derate that, except if if the maximum demand of a range of 8 3/4 or more rating has been calculated according to this table, but switch shall have an amplicity, then the neutral, when you apply the demand, then the neutral can be cut by 70%. Only for that size of ranges, only under these circumstances. This one is not that important. The tab over 50 amp, you can tab a 50, a 20 amp conductor from a 50 amp overcapacity device, not a big deal for us. But this exception number 2 for branch circuit is a big deal. Please highlight this. Okay? So what does that mean? What does that mean? Meaning here's my range. If my range is, suppose I have a range of 9 kW, 9 kW is more than 8 3/4, this must be at least 40 amp. That's what this is telling you. At least 40 amp. And then the conductor has to go with 40 amp, probably would be number 8. Conductor. That's what it's telling you.
What would be the circumstance where you have that? This is related to the section 1.
Take this. 2 ovens and a countertop. That's a tab. Right? You take a branch circuit in a J box, you tab a conductor, a bigger conductor to a small. A tab is a bigger conductor to a smaller, to feed the smaller ones. That's a tab.
Okay.
So make sure if the overcapacity device there is 50, the smaller conductor cannot be less than number 12. Why number 12? Because 20 amps.
So
That's if you
that
use.
would be the explanation why.
Yep. Yep. Any question, guys, about this? Any question about this? Now, the second hour, I'm going to go over an example that put all these together, guys. Detailed one. We're going to size branch circuits and neutral, feeders and neutral. As we go through, I want you please to keep in mind the 40 amp minimum for these ranges, and the neutral branch circuit can be derated, and also the feeders neutral can be derated all the time. So keep these in mind. Let's take 5 minutes break, and we'll get back to the example. Okay, so as I said, we need to size the feeders, which is the black, the overcapacity device for the feeder. That's number 3. The feeder, number 4. We need to size all the blue are branch circuits. We need to size overcapacity device for each one of these, as well as a branch circuit conductor each. The red is the number of appliances, and the blue, obviously, the sizes are in kW for each one of these. If you have a R, it's range. Otherwise, it's a countertop unit, cooking unit, or an oven. Any question, guys? The last one here, I threw that one for the example, guys. It tells you I decided to be lazy to pull a branch circuit, tab the branch circuit in a J box, and feed 2 ovens. O's are for oven, and 1 cooking unit, Remember that little exception that note number, what was it? Number 4 or 5? Cool. So let's go and size this. I need somebody with a nice calculator that gives answers. Number 4. Nice stuff. So I'm going to start with the branch circuit and overcomputation device for all these equipments. By the way, Ashley, I said I have 6 of these. I'm not putting them on the same branch circuits. I have actually 6 branch circuits here, 5 branch circuits here. Does that make sense? I'm not grouping them. I'm having a branch circuit for each one of them. The only time I group on one branch circuit is this right here. Cool? Just to give you an idea. All these numbers are single branch circuits. So there's a lot of branch circuits coming out of this system. The voltage system, just to be consistent for this, the voltage system here, let's use a 240 volt. So we know slash 120 volt, single phase. Single phase. So we need to, and all these equipment, we're going to assume all these equipment, because I need to size branch circuits. I'm going to assume all these equipments are 240. We're burning all of them at what voltage? 240. If it was 120, what would you do? You just divide by 120. We're going to burn all these equipments at 240. Let's go size them. Give you a few seconds to write them down.
Is this what you were talking about? You did it's new, or do you always?
I've never done that. I don't. I usually I do this. No, I've never done this example. I do something similar. Yeah, you guys, you see, you open a can of worms, man. I do this with the exam prep guys when we teach the master and exam and for. But it's a good example since you guys. I usually do neck. I just concentrate on number 4 and number 3, the feeders. That's all. I care about the feeders of this. Because I assume the branch circuits you guys have done that. Okay, it's really not a whole, you're going to see it's very easy. It's not a whole lot of work. It's Ohm's law. All this stuff that we're looking at is Ohm's law, guys. Okay, so shall we number them so we know where we are, guys? I'm going to go ahead and I'm going to use number black here. This is just sequential numbering here, so I know which one I'm working with. This is 1, this is 2, 3, 4, 5, 6, 7, and I'm going to make this one 8, 9, 10, 11, 12, 13, and all this thing is going to be 14. Just for the sake of managing the branch circuits, So when I say 1, we're doing number 1 branch circuit. Okay? Cool? As I go through. Cool? Everybody's okay with that? Cool? Any question, guys, before we go? Any question about what's given on the board? We have a panel, and you guys are designers and engineers. You need to size this panel and feed the branch circuits. Isn't that what we do? And then you guys also electricians, you can go grab your conduits and cables and go wire them. Right? But you can't wire, can you wire these systems without sizing them? You can't wire them without sizing them. Let me know, Phil, when you guys are done with that. Okay, now I'm going to be referring to the rules fast as we go through, guys. So you're going to have your code book open at page 66. That's 250.55, 220.55, page 66. And these are the rules I'm going to be applying. These are the rules that we're going to be applying. Okay. Just to give you an idea, I did it for mine. I'm going to help you guys group them. I call this is grouping. I'm going to use this blue to group them. I'm going to tell you that this one, just to group it, I'm just going to put these here are grouped together. And this will be not number A. Can you guys see? I'm grouping the ones that is going to be under A. I'm going to group these two. These two are going to be B. These 3 are going to be actually C, and also these all the way. So we have 2 and 3, yep, and okay, and 9, 10, all the rest of them here, all the way to 27, all 8.5, all the way to 10 to 12. These are all one group from a functioning point of view, and these all another group, and of course this is a group by itself. What does a group mean? The rules that apply to each one of these sets is going to be different. If you look at these, if you look at the first 1 and 2 guys, they are, what's the problem with 1 and 2? They're not in the table. The table doesn't cover them. 1 and 2, the table that we have does not cover them. Does that make sense? Doesn't cover them. The table starts with over 1 3/4. The table starts with over 1 3/4. So 1 and 2 doesn't cover them. Here's A. This is A, right? Column A. This is column B, right? Up to this is column B. Now these are column C immediately, with all of them less than 12. This one column C, but they're more than 12. And this one is the exception. The exception when we do the branch circuits. But 6 and 3.5 and 4, this will be also under column. Which column would that be? Just look at the numbers. It's column B, right? Column B. Does that make sense, the grouping? All right, let's go do them. Let's start with, when we do the branch circuit, the numbers doesn't mean anything. Number 6 and 5, it's all 6 circuits, 6 branch circuits. So it doesn't matter in terms of branch circuits. Okay, let's size branch circuits, and then we do the feeder. Okay, I'm going to go ahead, guys, and do the following. Branch circuit sizing. For the branch circuit sizing, I will size number 1. This is number 1, which is actually this should be number 1, branch circuit sizing. Sizing the branch circuits. And if I write sizing good would be nice, huh? Okay, I need somebody with a good calculator and ability to do that one. Okay, so let's see. We started, so can help me guys with that one. I'm gonna do 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12, 13, and 14 is all of them. Okay, I just numbered myself so I don't have to refer to this. You guys have all this? Yeah? No? Okay. So we're going to go size the branch circuit. If you guys want to start, if you look at 1 and 2, 1 and 2 are not even covered by, 1 and 2 are not in the table. How do you size the branch circuits for countertop, cooking unit, and oven? By the nameplate. So we're going to go do the nameplate. Ohm's law calculation. Chris, can I move on or no?
Isn't that covered by small appliance?
Ranges are a special type of small appliances.
I mean, the first, the ones that are 1K.
They're cooking units, but they're less. So I don't apply small appliances rule like 1.25 and all this good stuff on them. Here's what I would do. So let's use the first one. I'm going to use number 1, guys. So this is calculation number 1, but equipment number 1. Equipment number 1. So branch circuit. I'm going to use equipment number 1. Equipment number 1, it's 1K. So take I need to find the amps. I equal 1K divided by the voltage 240. Anybody can give me the answer for this one? Have a calculator handy. So we're going to have a 1000 divided by 240 equal 4.2. This will be a 4.2 amps. From here, I'm going to go size directly, guys. I'm going to size the overcome protection device 310.15 B16 under 60-degree column. and the conductor will be, these are single phase, so I'm gonna, with no ground yet, so I'm gonna have two conductors. Let's say that these were, let's just say that 24120 system, three conductors, number 14, done.
Aren't they all in one circuit though?
No, they're not one circuit.
What was that other place where you put the circuit number for each?
These one, this one is 6 1kW. Each one of them has its own circuit. You can group them.
Oh, one of those numbers that is circled.
That one, that's just number of, that's just to relate to where the calculation is.
Oh, okay, it's not the branch 30.
No, it's just calculation. What I'm going to do the calculation.
Oh, okay, because it looked like you have a old full seat, overcurrent protection device and then 6 ranges at 1K. So it looks on the side.
So this number is the calculation number. This is the branch circuit. This is the overcapacity device. And I'm going to do them all for the branch circuit, then go do it for the feeder. What's not clear?
Number one, the ones in black, that's just our reference.
Just reference to for the calculation.
So we don't care.
I'm looking at the diagram.
Okay, what's with the here's 1K. These are the number of the equipment.
6.
Yeah, but these are 6 branch circuits. I'm only showing one of them.
Okay, that is.
Yeah, 6 branch. Otherwise, it will be chaos. Only 6 branch circuits, 1K each.
Okay.
I'm showing only one of them.
All right.
But okay, so this is, and then from the same calculation, guys, from here, I want to do the overcapacity protection device right away. The overcapacity protection device next, the smallest overcapacity protection device you can get is what? 15 amp. And this is where this come from, 240.6. Okay, I'm not going to be writing all this stuff, guys, but that's what basically we're going to be doing for all of them. And since we're doing it here, I'm going to say, I'm going to do 1 and 2 at the same time. 1 and also 2 here. Overcurrent protection device for branch circuits. So I'm going to do 1 and 2 in the same calculation just to gain more time. Okay, here's 1, 2. Let's do 2. The rest of it is just tedious work, guys. The rest is tedious work. I have the second one, guys, is 1 3/4. 1 and so I equals 1.75 divided by 240. Where's my calculators? 1.75 divided by 240 equal. I have times 1.3 equals 7.3 amps. 7.3 amps, right? Take this one from here, the same table. You're going to get number 3 conductors, number 14, and what's the overcapacity device? 15 amps. And I'm not going to write where we got them from. Any question guys about that? Straightforward, right? Branch circuits. For number 2. Does it make sense, Chris, now, as we go through?
That was the diagram.
The diagram is, okay.
Oh, I get it.
Okay. So number 2, let's go to number 3. Straightforward. What's number 3? Number 3, I have 2K. Okay, I have find I for 2K. 2K divided by 240 equal. Take your 2K, 2, 1, 2, 3, divide by 240 equal 8.3. 8.3 amps. The same calculation, this will be 3 conductors, number 14, and also what? 15 amps. Done. 3 conductor. Is it wrong to put a number 12 conductor here and 20 amp? It's okay, no problem. But you really, all what you need is for this type of size up to non-continuous. They're non-continuous. They're not considered continuous. So all what you have to do is number 3. Okay, let's do number 4 right away. Number 4 is the same thing, guys, and you get the scoop of things. 4 is 3K now. We're gonna do it for 3K. Divide by 240 equal 3, 1, 2, 3. Divide by 240 equal 12 and a half. 12.5 amp. Take this one. That will be a 3 conductors. Still 3 conductors. Number 14 and what's the amp? 15 amp. 3 conductors, number 14, 15 amps. Are we cool? We're still less than 15 amps. So we still can't get away with number 14, right? Why 3 conductors, 2 hots and a neutral, assuming they need a neutral? If they don't need a neutral, Ashley, what do you do with the third one? Open the window and throw it. Really doesn't matter. Okay, let's do 5. So for 5, and you get the hang of it. For number 5, now number 5 is also cooking unit 3.5. 3.5. Take 3.5K divided by 240 equal 3500 divided by 240 equal, I have 15 amp. So 15 amp, I can immediately go with 3 conductors number 14, non-continuous, they're non-continuous, and a 15 amp circuit breaker, non-continuous. Okay, all these are cooking units and ovens or countertop units. Either ovens or countertop units, right? Now we finished up to number 5, okay? I'm going to switch to a different page to go to the ranges. We move to the ranges. The only difference for the ranges is they allow you to apply the demand factor from the table. That's the only difference. Everything that we have done right now is for ovens and cooking units. See how easy that is? Ohm's law, go all the way to next. Now, Zach, my friend, if you say, you know what, Chad, I want to go for a 20 amp for this baby, and number 12, be my guest. Any question about the branch circuits up to 5 branch circuits? Can I move to the next? No, slow. Chris, my friend. Makes sense, no? Okay. Any question? Okay, I'm going to switch to a different page, guys. We'll continue doing branch circuits. So I'm going to do number 6. Number 6, I'm going to remind you, is a range. Can you guys see it? Number 6, everybody knows number 6 is a range. If it's a range, there's a few calculation different. Range. What's the range? The range is 8 3/4. So I have a range 8.75 kW. You need to take it's a range. It's a range. Range. So for this one, you need to use. You can use the table, no problem. So you can use the table, no problem. 8 and Number 6 is 7. Okay, thank you. Number 6 is, it's still range, right? Number 6 is range is 7 kW. Okay, if you guys go, it's still a range though. If you go 7 under column B, right? It's column B. So what does it say for one range column B? Take 80% of that baby. So here's what they do, or what we do. Take this one to table 2. 250 dot, what is it? 220.55. 220.55. Oops, 55 under which column? B. And if you guys go there, that will get you, take one range, multiply it by 7, multiply it by 0.8. And what would that give me, all equal? 0.7, oops, 7 times 0.8. They give me 5.6, thank you. That will give me a 5.6 kW. Piece of cake, Chad. Here's I equal 5.6 divided by 240. And we apply, now we start doing all the calculation based on the table. 5.6 divided by 240 equal times 123 equal 23 amps. 23 amps. Now take this one, would you, to 310.15B16. I'm going to take this one to 310.15B16 under 60 degree column. What's the overcaptation device? I'm sorry, the conductor.
30.
Number 10. So the 3 conductors, number 10, and 3 conductors, number 10, and overcaptation device. What's the next overcaptation device? The next overcaptation device, I can use 25 here. I can use 25. or I can size based on the, this is where kind of a, so really, technically, I can put 25 here, 25 amp, or I can put as low as high as 30. I can put 25 or 30, because what? 30 goes with 10, no problem. 30 more than what I need. So I can go 25 or 30 on this particular one. Okay, this is for number 6. Number 7. Number 7, guys, is the same thing, range 8 3/4. It's a range, and it's 8.75. So you're going to take this one to the same table, guys. Table 250 220.55. 220.55 under which column now? Are we still on the same column, B? Yeah, thank you. B. So the same calculation, guys. 1 times 8.75 times 0.8. Chris, what do we have? For this,
You round up, it's 30.
the KW though.
Oh, uh-huh.
The KW
7,000.
7K. 7K. If you take the I to 7K divided by 240, what do you get? 7 divided by 240. Close to 29.2 though. 29.2 amps. Then take this one to the right table, which we have been using. That will get you a number, 3 conductors. Number 10. And what's the overcome protection device? The same thing. Overcome protection device will be 30 amps. Okay. Up to this point, I'm okay. Except it's three quarter. And I have an issue with that one. The ampacity not less than the rating of the branch circuit, not less than the maximum rating for the circuit for ranges over for ranges of 3 or more. But this is up to this point it's okay, guys. But there's an exception for this type of ranges. There's an exception for this type of ranges. I'm going to write it in green here. So if you go to 210 dot, write this one here, 210.19.19a.19a3. A3. If you guys go to this, it will tell you for this size of range, you cannot use this than 40 amp no matter what, even if your grandma wants you to use it. You can't use this than 40. Based on this, my overcome protection device has to be 40 amps, right? Based on that particular rule, right?
For number 7.
For number 7. For number 7. Only for number 7. Only for number 7. Because if you guys read it, it says anything 8 and 75.75 or higher, no matter what your grandma tell you, what your calculation tell you, you can't go less than number 40. Good, here's number 40. And can you just tell me if the conductor is number 40, can I still land a number 10 and number 40? I can't land number 10 and number 40. So what's the number 10 have to be up to? 8, thank you. So this is what your calculation for that particular one. Any question guys about that? That's because of that little deal of Brach circuits. So no matter what you calculate, if you are 8 3/4, they want you to use minimum of this size or larger. Any question guys about number 8? What was the problem with number 6? Why didn't we care about number 6? Number 6 was 7. 7 is less than what they asked for in this exception. Chris, make sense? Shall we go to number 8? Number 8. I'm going to remind you, for number 8, does the same rule apply for number 8? Yes. So when you do a calculation for number 8, if we came up with something less than number 40, should I use this number 40? No. I should have used this number 40 for number 8. Okay, so let's go. I'm going to do number 8 right here, probably a different color. Number 8. Number 8, I have a range. The range is 9K. if you guys go to do the calculation for 9K, it will tell you 1 times 9 times what's the derivative is 0.8. And what would that give me, Chris? 0.8, 0.8 of 9?
Where are you getting the money from?
That's
9.
C.
Yeah, it's 9. I have to go to column C. You're not so right. You guys are good. Okay, so let's do that one. So you're going to go to table here, table 220.55. Which column? C. So in this, no calculation is needed, will you? So that would give me immediately number what? Number for 1.
Give me number 8.
Number 8. That'll give me number 8. 8 kW. Okay, then you do the calculation, you do the math on 8. I equal 8K divided by 240. Did we do the math for K, for 8? We didn't do a math for 8. We did. Okay, so what would that give me? 33.3 amps. If you take it to the right table, that will get you number 3 conductors, number 8, right? And if you take it to the right column, it will give you also, do we have a 35, Chris, overcome protection device? I think there's 240.6. We have 35. So, thank you. So this should be, well, let's say this 35 amp, but there's one little problem. This range is more than, it's 8 3/4 or more, so I can't use 35. So what's my only option then? 40 amp no matter what. So here's my conductor then, and here's, why can't I use 35? Because of that rule. Because of that rule. Does that make sense, guys? So I end up with the same thing like number 7, right? 48. Okay, can I move to a 9? And you guys can get the rhythm of it. So it keeps going the same rhythm. Let me ask you guys, for item number 8, how many ranges do I have of this size? I have 7. So I will have 7 circuit breakers, 2 pole each, 40 amp. We'll count how many circuit breakers we're going to have by the end. It's going to be a big panel to feed all these systems for me. Any question guys about number 8? If you look at number 9, it's 10. 10 goes under which column? C. We have not exceeded 12 yet. So, okay, so I'm going to go directly. Can I move? No? Slow? Yes. Okay, let's do 9. For 9, what's the size of the range for 9? 10K. I have a range. My problem is it's 10K, and I need so I have to go find it. It's under 220.55 table under C. So this will be 1 times 10. Oh no, not 1 times 10. What's the range on the C? 8, no matter what. So it's still 8. So I'm not going to do the same calculation. So what do you think we do the calculation for 8 we're going to end up with? If you do the 8, we've just finished it. I equal 8K divided by 240 equal what? 3. Can you give me that one? Yeah. That's 3.3.
That's 3. Same one as number 8.
You know what? I'm actually going to say, because it'll be identical. We did the same thing. So I'm going to say same as 7. Same as 8. Okay.
10 will be the same thing.
Thank you.
12K.
You got it. Same as number 8. All right, let's do 10. See how nice it goes fast. Range equal for, what's 10? 12. Up to 12. 12K. Okay. So 12K, let's see what 12K, the same thing if you guys do it, the same table. 220.55 CT, that will give you 8K. And we already did the calculation for 8K, so same as number 8. Don't even mess with it. Don't even, it's not worth working with it, right? Yes, sir.
Please, I got a question. You said you have 10K, you have 6 ranges.
We're just calculating one range at a time.
We're calculating branch circuits.
Okay. Because why I'm asking that question that
Why did we go to 1?
yeah,
Because there are 6 branch circuits. 1, 2, 3, 4, 5, 6. Each one of them is, what was the size there? 10, but I'm only showing 1. Does that make sense? Well, I'm not doing the feeder, I'm just doing the branch circuits.
okay.
There's 6 of them. Because if I drew 6, it would be
No,
disaster.
no,
Does that make
what-
sense?
What
It's,
I'm asking now,
why did we go to 1?
yeah, on the table?
Because we're sizing for 1.
One range.
1 range, 1 branch circuit. The other 5 are the same. So what we size 1 that's going to be similar for all the other 6. Okay, you guys, does it make sense? Am I making sense here? 1 branch circuit, the other 6 are the same. The other 5 are the same. So we're just doing it for 1. Why did I put 6? The question then would be, why the heck did you put 6, Chad? Because it's going to make a major difference when we size the feeders. As we do the feeders, it's going to make a major difference. It doesn't play any role in the branch circuit. Okay, good point though. Let's do number 11. Let's see if 11 is going to be the same. Take 11. Okay, I have a range. What's the range for 11? I have, my 11 is 16.5. 16.5. Okay, now, you need to apply the table to 16.5. Hold your horses. Now, when you apply the table to 16.5, is this 12 or less? No, it's more than 12. So you're going to apply note number 1. Note number 1 on it. So here's what you're going to do. So this will be 220.55 C. Also, note number 1. If you guys read through note number 1, what's the demand for 1? 8, right? The demand for 1 is 8. Plus, you're going to increase the 8. You're going to increase the 8 5% for every 1 kW larger than 12. This is very important. So here's my 16.5 minus 12. That get me 4.5. That will approximate to what? To 5. Then, oops, here you go. This is number 8. Then I'm going to increase, so this, then I'm going to increase it 5. This is step 1. Step 2, you're going to take 5 times 5%. That'll give you an increase of 25%. Then your total have to be increased by what? For 1.25 times 8. Can you guys do me that? 10?
Yeah.
Well, oh, that makes sense. 10 kW. Any questions about this? We apply the rule for the branch circuit. Why? Because note number 4 tell us that you can use the table, demanded table for branch circuits too. So number 10. So what do I need to do now? Do the whole calculation based on number 10. I'm going to do it right here, guys, just to finish this one right in this corner here. So I'm going to find, just going to use red here. So I'm going to find I equal 10 kW divided by 240. What would that give me? Equal 10,000. Give me 42. 41.7 amp. Okay, cool. No problem, Chad. Then you take the 41.7 amp. Take it please to 310.15 B16 under 60-degree column. What's the conductor size? Number 8. Can number 8 get us there? Chris, can number 8 get us there?
No, for number 6.
You have to go to number 6.
Unless you're at the 75 degree.
No, no 75. Everything is 60. So you're going to go to number 6. Okay. Number 6 can give me what's the amp up to 55. It will give me 3 conductor, number 6. Cool. All right. So let's take the same thing we need to go, guys, for the overconduction device. The overconduction device for 1.7. Take it to 240.6. What's the next standard? 50? Next stand, 50, right? 41 point, is there 45?
45.
I can use 45 amp, or I can use 50 amp. Your choice. You can use 45 amp on this, or you can use 50. Can the 50, Chris, can the 50 protect number 6? If you look how much number 6 can give me, 55. Number 6 can give me 55, and my overconduction device is 50. Am I okay? Yep. My conductor can give me 55 amps, and my overconduction protection device is 45. That's okay? Okay, so either one of these would work.
Isn't the panel well over 100 amps?
You can have a panel for 600 amps.
Well, if it is, then you were supposed to use the 75 degree power.
Yeah, but we're doing branch circuits, remember. Up to this point, we're sizing branch circuits. Yeah, we're just not touching anything. We're sizing branch circuits.
So it's just the individual
Yes,
breaker.
yes, individual breaker. You're right about the service, but the individual breaker are 75. Good point. Any question, guys, about number 11 before we move into number 12? See, Nick, what kind of worm you open?
Good work.
It's a good worm. I do it, as I said, do it for the master exam, but not. But does that make sense, though? Step by step, it's all repeating itself. Okay, let's go to number 12, would we? Can we do number 12 when you guys have a chance? Phil, my friend, William. Guys, if we're doing more, especially Ashley and Zach, guys, if we're doing more calculation than you guys have done, we're designers. You're expected to do all this calculation. They pay us not to bend conduits. They pay us because we can't bend conduits legally. We're not licensed, bonded, or insured. They pay us to do the calculation, the sizing. So, okay, so that's number 11. Number 12. Let's go to number 12. Okay, number 12. For number 12, what do we have? We have a 20K. Oops, 20K. So I have a range, and my range is a 20K. Okay, now, Nick, you agree with me that we go to 220.55 under column C, and please look at note number 1. Column C, note number 1. So what was this one from the get-go? You have 8K from the get-go for one of them. You have 8K from one of them. Now we need to increase. You take the 20 minus 12, give you 8K, right? Then you take the 8, multiply it by 5%. That will give you what? 20, no, what's 8 times 5? 40? 40%. Then your demand will be 1.4 times 8. Aladipo, how much? 11.2K. KW. Does that make sense what we did, guys? Because it's more than 12? Okay, now let's go apply the rule for it. I. Let's go find the I. Find I equal 11.2K divided by 240. Press, what do we have?
47.
Thank you. 47 amps. Take this baby to 310.6.15 B16 under 6 degree column. What do we get?
Number 6.
Thank you. 3 conductors, number 6 again. And take the same number, guys, to 240.6. What do you get? 50, right? 50 amp. Done. So 50 amp, number 6. See how easy that is? Number 12. I'm going to roll into number 13 right away, guys. 13 because it's very similar. Number 13. The reason, Phil, I picked number 13 because that's as high as the table can go. After number 17, you're on your own. The table does not cover that one. After 27. As high as you can get is 27. So range equal 27 kW. Take this to the table. The same thing, it's 8K from the get-go. And then you're going to take the 27, subtract 12 from it. That will give you 15, no? 15K. That's from here. Then, if you do the 15 multiplied by 5%, what do you get? 75%. And finally, you take 1.75 and you multiply it by 8. And what do you get, Oladipo?
That's 14.
How much?
14.
14? Even. 14 kW. So for this branch circuit, by demand, the calculated load for the branch circuit is 14. Do the math on it. The rest is piece of cake now. Find the I equal 14K divided by 240. Chris? Amps?
58.
How much?
58.
58.3 amp. Now I think we exceeded number 6, aren't we now? Because 6 can give me 55. So I'm going to go to 310.15 B16 under column, under 60-degree column. What do you guys get? Number 6, no, number 4. 3 conductors. Number 4. Take also the same number to the next overconduction device. What do we have? 60 amps. Done. Done. Oops. Here's all the branch circuits. One more to go. Any questions about this before we do the last branch circuit, which is number 14? The reason why I made number 14, guys, because it's kind of a special, because it's 2 ovens and a countertop in one kitchen, one area. That's the assumption for number 14. Does that make sense, guys? Ranges, countertop, units. Let me know when you guys are ready to go to the next one. So besides the overconduction device and the branch circuit for each one of them. Ready? Yes? No? All right, let's do number 14. Number 14 is piece of cake. Number 14, yes, my friend, I have 2 ovens. Let's do number 14. I have a cooking unit equal 6K. And I also have an oven equal 3.5, and another oven equal 4.5K. All of them are in the same area, fit from the same branch circuit. The code says, not number 4 says, guys, add them up together. So the first thing you need to do is add them up. So 6 plus 3.5 plus 4.5. Where does this come from? This is from note number 4. Add them up. Okay, Oladipo, what do you get? How much?
14.
14 even? 14 kW. Okay? Then, for all practical reasons, treat them as a range of 14. How do you treat them as a range of 14, Oladipo? You take them to table 2, 20.55, on which column? C. Thank you. What would you get? 8. 1 second. We got 8 first for one of them, one range. Treat as one range. Then you need to increase 14 minus 12, get you what? 2K. Then you're going to take the 2 multiplied by 5%. That will get you what? 10K. And the last thing you need to do is take the 1.2 times 8, and that will give you what?
1.1.
1.1 is 8. It's 1.1.
It's 10%.
And 1.1.
Oh, I'm sorry. Why? Oh, 1.1. That will give me what?
8.8.
8.8. Oh, it should be 8.8 kW. I think I lost my brain behind me here. Okay, let's do that. So let's take an I equal 8.8 kW divided by 240.
96.7.
How much?
96.7.
36. 36.7K. Take this one to 310.16. 310.15 B16 60-degree column mode. They give you number 8. 3 conductors. Number 8.
40 amps.
And what's the overcome protection device? That's easy. 40 amps. Now bonus for you guys, I'm not going to do it. This is the one that feed all of them. Now if I ask you the tabbed conductors, the conductors that, remember that there is a tab conductor here, 1, 2, 3, there you go. This is, we size this one here. How about these little ones? If I ask you to size this tab conductor, these ones, how do you do them? Exactly how we did these. Based on the volt amp, take this divided by 240 and size the conductor. Where's the overcome protection device for this one? None. This one, none. This one, none. They don't have an overcome protection device. All of them, they do have one here, which is now, this is 14, number 8. Come over here, then you tap it most likely from number 12, 12, 12 to go feed the others. Okay? So go all the way, all the way, all the way, all the way. Any question about that one? This is just the branch circuit coming to the J-box. Yes, sir.
That what we just did, let's say it was less than 40 amps, so that the volume will
Yes. Yes, you treat, absolutely. If it was less than 40, then you treat it as a range. What was the range? Less than 40 less, 40 minimum. Treat it as a range. Any questions about this? So we sized all of them. I'm not going to do the number, I'm not going to do size the tabs. This is a tab for this, and a tab for this, and a tab for this baby. And this is what we're saying is right here, tab them, each one of these equipments. What we sized, this was my 40 here, and this was my number 8. Then these conductors, guys, you size them based on, we size these conductors, the tab conductors, we size them exactly like we just did. We take the 3.5 divided by 4. Shall we do it just because? Because it bothers me. Let's do the quick. I'm going to do them right here. Just stay in the same. I'm going to do the first one, I equal 6. 6K divided by, now they're not ovens, divide by 240. What do you get? Press quick.
25.
25 amp?
Yep.
25 amp. Okay, what's the overcapacity device? What's the conductor then? Number 10. How many conductors? 3 conductors, number 10. Okay, done with this. Let's do the other one. Oops. Where did we go? We want one step back. Okay, let's do the other one. The other one is I equal 3.5. 3.5 followed equal divided by 240. Give me the amps for you.
14.6.
How much?
14.6.
14.6. What's the conductor size? It's less than 15, so that will be number 3 conductors, number 14. Okay, that's if the overcapacity device was 50 though. Look at our overcapacity device, not 50. It was right 40 for this. Okay, now the last one, guys, I equal to the last one. What was the last one? 4.5, 4.5K equal divided by 240. 18.75. That will give you how many conductors? 3 conductors, number 12. Thank you. Okay, so these conductors, guys, what did we say? We had the first one. This is number 6. This is 3.5, and this is 4.5, and the number 6 was number 10, right? And this one, the little guy, was 14, and this guy was 12. Is that okay? Tabbing him, no problem, in the same area, same proximity. So you bring number 8, Chris, and you put it in a box, and you tab these conductors to feed these 3. Only acceptable if you're using them in the same room. That's why I took this example, just to get you how you can 14, 12, and 8 tied together in one box, feeding all these equipments, and the overcurrent protection device is 40, that's okay.
There's a distance limitation.
Yeah, but that's why they say in a close proximity in a residential. How far would that be? I mean, yeah, it could be, yeah. For this one's okay. Otherwise, you're going to go to the rules of the tab, guys. There's 10 rules and 20 rules. Okay. I'm going to do the feeder, guys. Do you need a 5 minute break before we do the feeder? The feeder is going to be straightforward. Taking all of them and do the feeders, and we're done. 5 minutes break. Okay, let's go ahead and start doing my feeder here. To do the feeder, I want to remind you guys, I want to go all the way back to the graph that we did. And I want you to do the following. Do me a favor, when you go to the graph, just when you go to the graph, can you do me a favor? Can you do the following? When you go to the graph, right here, I want you guys, these two, can you put column A? See how we said we group them? Right, the first two, this will be column A. Do you guys agree with me? That will apply column A on them. This will be, just put A here. These 1, 2, 3, 4, that will be column B, right? And also these will be column B. Can you guys see that where column B is? These 3 and these 3 are going to be column B, right? Are you with me, guys? From the 220.55, this is, these 3 are column B, these 3 are column B.
Isn't that column C, when you apply it as 14 to a range?
Where's the 14th?
Down in the lower right-hand corner.
Oh, that, when you add them up?
If you add them up, you pretend it's a range.
But note number 4 is only for branch circuit. We're doing feeders. I want to remind you guys, we're doing feeders now. Remember, we switched, we're done with the branch circuits. Note number 4, if you read it, it's only for branch circuits. We're done with the branch circuit. We're done now. We're going to go do the feeders. For doing the feeders, we care less how they're wired. We're going to add them all up based on where they sit in the column. Note number 4 does not mean anything when it comes to sizing feeders. Okay, so these are B. Are you guys with me? All of them are under B. These are all also under B. And this is under B. How about these guys?
C.
These are C, and these also are C. Okay, so based on this, I'm going to go now size the conductor. How about these? Oh, by the way, how about these then?
They're not on the table.
Thank you. Can you guys see that? I'm going you to put not in the table. So we're going to apply a different rule on them. Not in the table. These two sets, they're not in the table. Cool. Yes, sir.
Why is that? Why wouldn't they read the column A? That's what's going to have to get in.
Because if you read Article 250.55, it will tell you that table applies for anything larger than 7 and 1.75. Yeah, if it's less than 1.75, doesn't apply to it.
So are we gonna mess with that?
We're gonna mess with them.
Okay.
We're gonna mess with them right from the get-go. Any question how they are divided in terms of doing the feeder? And I will remind you, we're doing what? Feeders. We're done with the branch circuits. We're gonna do feeders. Cool. There's none. Here's A, B, C, C, and B here. Okay? So here's what I'm going to do, guys. I'm going to group all the nuns first. I'm going to do the nuns. Then I'm going to do the B's. Then I'm going to do the A's, I mean. Then the B's. Then I'm going to go to the C's and then add them up. Cool? Are you with me? We're going to do the nuns, the not, then the A, all the A's. We're going to do all the B's separate. And then we do the C's separate. And then we'll add the demand for all of them. And that's it. We're done. Any question about how we're going to do this? It's very important how you're going to approach it. It's a lot of equipment. I want to remind you now that these red numbers will count a lot, will mean a lot. These red numbers will mean a lot. Okay? All right, so let's go ahead and any question, guys, before I move on to finding the feeders? We're going to do the knots and A's, B's, and C's. Okay, let's keep going all the way to the feeder. So for feeder, I will size. So this will be 3 and 4, which is feeder conductors. conductors and overcurrent protection device. That's what we need to do. Okay, the feeder conductors and overcurrent protection device. All right. Here's what I'm going to start. I'm going to start with the not in the table. I'm going to do the first column is not. How am I going to do them? Let me say, okay, I'm going to just put a big star here. Not in table. Or table does not apply. Let's put it this way. Table 220.55 does not apply. Okay, let's go do them then.
That's for 1 and 2, correct?
And I'm gonna mark it here. So that will be for number 1 and number. So let's do them right here underneath it. So I'm gonna grab number 1. For number 1, guys, I have, how many of them do I have? I have 6 times 1K equals 6K. Done. For number 2, I have, how many do I have? I have 5 times, how many? 3, 1.75, right? 3/4. 1.75 Oladipo. Everybody knows where the 1 is. Load type number 1, load type number 2. That doesn't apply to, so what do we have? 8.75. 8.75 feet. Okay, anything else under the table does not apply to? No? So let's go to the second set. This is table 220.55. I'm going to say column number 8. All the stuff under 8. I'm going to apply all the stuff under 8. That will give me which number? That will give me number 3. So let's go to number 3. Number 3, how many number 3 do I have? I have 4 number 3. Are you guys with me? Right? 4 number 3 times, how many do I have? 2K times, what's the demand factor under column A for 4? Are you guys with me? 66 times 0.66 equal. So all of people's working on that one. While he's working, I'm going to do number 4. Number 4 is the same thing. How many do I have of them? I have 3 of them. Multiply each one of them by what? By 3K. So I have 3 multiplied by 3K. And what's? Oh, I'm sorry. We don't do it this way. We add them up. You're right. We add them up. So for 3 and 4, we're going to add them up. So we have the following. This is what you're going to do. I have 4 times 2K plus 3 times 3K. Add them up and multiply them for the demand factor for how many of them? 7. What's the demand factor for 7? Thank you, 56. Multiplied by 0.56. Everybody knows how to do this math? Add them up. That's what I did. I add them up and multiply them by the demand factor of 0.57. So what would that give me? So remember, these are, so we have to add this and this. I'm highlighting the stuff that I need to carry later on. Okay. What would that be? 9. This will equal 9.52. 9.5 is good enough. 9.5 kW. Done. This is for these 2. I put a star next to them because I'm going to carry them all the way down. I'm going to be adding them later on. Any question, guys, about column A, everything under column A, which is 3 and 4, all the 3s and all the 4 type of equipments, add them up. This is what I did. I added all the 3s up, all the 4s up, added the 3s and the 4s, and multiplied them by the demand factor for 7 of them. Why 7? Because I have 4 3s and 3 4s. Can't be more confusing than that. 4 3s and 3 4s. Any question is, anything I highlight in red and put a star next to it will be carried all the way downstream. Let's go to the B's. After the B's are the C's, and then we're done. So I will remind you for the B's, how many do I have, guys? I have a bunch of them for the B's. They're all under B. Can I move to the B? No? Let me see. Okay, so for B's. So I'm going to write here, table 220.55, column number B. Okay, I'm going to remind you guys, that will cover the following. That will cover 5, comma, that will cover 5 and 6, and also 7, and all the way to 14, all the 14 stuff. So how are we going to do that? Here's what we're going to do. Let's start with the 5. 5, I have 2 times what? Times 3.5, right? 3.5 plus. Let's go to the 6. 6, I have 9 times 7 plus. Let's go to the 8, to the 7. 7 is 8 times 8.75. Are you guys with me? Plus, keep plussing. We're going to go all the way to the 14. For the 14, I only have one of the 14. So I have 1 times 6 plus 1 times 3.5 plus 1 times 4.5. All of them have to be multiplied by the rating factor for how many? Let's say we have 2 plus 9, 11, plus 8, 19, plus 1, 20, 21, 22. Right? Am I right? Did I count them right? I have 22 equipments under B. So what's the rating factor for 22 equipments? 22 equipments is 0.26. Everybody's okay with that? So we're going to multiply all this by 0.26. Thank you, Oladipo and Chris and everybody else. So we're going to multiply them. Why 26? Because I have 22 equipments, 22 ranges and all this junk. I need 2 gentlemen or a gentleman and a lady to agree on the answer here. Chris, did you get it?
I'm looking at taking that higher one of the C column. The 8.75 one, taking that to the C column. That's why I'm staring at it.
Yeah. Well, then you can apply the C column for all of them then. Go do for all of them. Go 22C. What's 22C? 22C can give me what? 22C can give me 37. Let's see if we can get up with more or less than 37.
40.
40?
Yep.
40. Good point. So let's look at that one. Did we do the math? I need another person before we make a decision.
Yeah, 39.26. So
39.26.
26. That's what I got.
One more. 40.04. 40.04. Okay. KW. Okay. Now here's the moment of truth. Now all these guys are under B. It will give me 40. Now how many of them do I have? If I want to apply C to check myself under C, or under C, let's look at C. How many of them do I have? 22 of them. And I'm going to move myself all the way to table 220.55 under C, because that's my default. For 22 of them under C, what do you get?
You got 37.
37.
37.
KW. Now do me a favor now. Which one are you going to use?
That's it.
The smallest. I'm not going to see the more demand, but the smallest. So that's where 37, if we did our math right, that's what the one that you're going to be carrying if we did our math right. Because guys, for 20, all of them apply under C. For all of them apply under C. So for the, if you guys apply the same thing for, do me a favor, let's apply the same rule, because that also Let's apply the same rule for A. I went back to A. How many of A do I have? Chris, did I say? I have 3 plus 4, 7. Can you give me 7 under C? Table 2, 20.55. C. What do you get for 7 for C?
22.
How much?
32.
32 kW. 22, I'm sorry.
Much higher.
22 kW. So which one do you guys going to be using? The smaller number. See how we also apply it for A, but A, why didn't I check A from the get-go? The further away you go from the 8 3/4, the more likely that the A and B will rule. Okay. All right, so everybody knows why we did. So we picked the 37 instead of 40. Any questions about this? That's a number that we're going to carry downstream. Are we done? We still have to do C. Wishful thinking, Chad. Any questions about this before we do to C? Good.
It looks like a combination of taking the higher ones, putting them in C, and leaving the lower ones, and feeding them a little bit better number.
The lower ones in.
There are a significant number that can go in column B as opposed to all of them in column C.
But they all have to be under column. This is the default. Then the rest here, the red, I have to go B. I can't go A, right? My default is 37. Then I'm going to go to B and C. Can I get a smaller number than 37? And unfortunately, we did not, so we stick with the default. Okay, not a biggie. Any questions about this before I go to C? I want to remind you for C, guys, all of them are not under B or A for any circumstances. They are different sizes, and some of them are larger than 12, and others are more than 12. So this will be note number. This will be note number 2. We're going to apply note number 2. So okay, let's go do C. So table number or table 220.55, table 220.55, column number C, and note number 2. You're going to apply column C, note number 2. If you guys look at that baby, here's what this baby tells you. Okay, let's start. And that will apply to 8, 9, 10, 11, 12, and 13. So I'm going to say, where does it apply? That applies to 8, 9, 10, 11, 12, and 13. All these branch circuits apply to all of them. Okay, let's go do it. Anything less than 9, anything less than 12, what do you do with it? Make it 12. So the code says make everything 12, average them. So first of all, let's go, well, let's see how many of them do we have first. How many of them do we have? How many of them do we have? We have 27, right? Based on 7, 6, 5, 4, 3. So I have, everybody can agree with 27? If for 27, guys, go to table 250.55 under column C. What's my demand for 27? For 27, I need to do calculation for 27, right? I have 7, 9, 5, 3. Are they 27? So 5 plus 5, 10, 10, 27. Yeah, for 27, I need to do a calculation. 26 to 30, here's what they say. 15K plus 1K for each range. So it says 15K plus 1K for every range. How many ranges do I have? 27. So do a math for me, will you? So 27 plus 15 is what? 40. How much? 42 kW. Everybody knows where we came up with? For 27 of them, the demand is 42. Had they been all 12 or less, I'm done. But there's one problem. Some of them are 12, some of them are less, some of them are more. So I have to do note number 2. So keep this 42 in your mind first. Okay, let's go do the second calculation. Second calculation says anything less than 12, make it 12. So for the 9, what do you think I'm going to put for the 9? So I'm going to have 7 times 12 plus 10 plus 6 times 12 plus, I'm sorry,
Yeah, and we multiplying there on, we are adding 27. That's,
1 times 27 plus 15. It says 1 kW for every range, so you multiply.
times 27.
Yeah, so 1 times 27, 27 plus 15 is 42.
No,
This is a plus.
yeah, that's plus this multiplication.
Just multiplication.
So we are wrong.
Why? 1 times 27 is 27 plus 15. The multiplication is by the 27. Here, let me put the brackets, maybe you'll make it here.
Okay.
Would that make sense here?
Okay.
More sense?
That's all.
Yeah. Oladipo. There's, what do you call it? Process of operation, sequence of operation. No, I see you. I see your point. Okay, so the brackets are there. Good with the brackets? All right, so 7 times 12 plus 6 times also 12 plus 5 times 12 plus, we're not done yet, plus 4 times 16.5 plus 3 times 20 plus 2 times 27. Okay? Who's going to be my hero? Who's going to give me the answer for this? And I need 2 gentlemen or a gentleman and lady to agree on that. If we do the multiplication right, I want to highlight these guys in red because these, based on the note, they have to go 12, right? The other one is already 12. So the 9 and the 10 have to be 12 because they're less than 12. You have to up them to 12. Okay, that's why I highlighted them. So 7, 12, 6, 12, 5, 12, 4, 16.5, 3, 20, and 2, 27. Add them up. Chris? Looking at something? Oladipo? Ashley? Anyone? Do you guys want 10 out of 10 in the participation or no? Okay. I need 2 people to come up with the same answer, guys.
396.
396?
Yeah, I'll agree.
396? Okay. 396. 396. Okay. The second step that you need to do is you need to take the 396 divided by how many ranges do we have? 27, right? Divide by 27. What's your average?
14.7.
14.7, right? Anybody disagree? Agree? Second? Do I have a second? Okay. And this will approximate to what? 15K, right? Because that 0.5 goes up. 15K. Cool. Done. Then you take the 15 minus 12, give you what? 3, right? And the last step is you take 3 times 5%. That will give you 15%. That's your up, 15%. And the last thing you need to do is multiply 1.15 times, what's the number, 42? 42. What's 1.15 times 42? That's my demand for all these babies.
48.3.
48.3 kW. Done, thank you. And that's the demand for all these put together. That's the demand for all these put together. We're done. We're going to add them up and size the feeder now. Any question, guys? How we did them? The ones that I circled, they were less than 12. I have to make them by code 12 from note number 2. Says, oh, by the way, anything less than 12, and that rule applies to it, please make it 12. So I have 48.3. The rest, I want to add all these steps, divide them by the voltage, size the cable, and size our computation device. I'm done. So Okay, Nick, my friend, you're gonna be giving me the which is B. We started right here, so we're gonna take the 6K. Anybody's gonna give me the ones that have star next to them. Who's gonna give me these? 6K, 6, 8.75. Okay, you guys will give it to me, and 9.5, and all the steps. Okay, all right. Oladipo, let's go. Total demand. Okay, Oladipo, the first one.
6,
First one was 6K plus
8.75,
8.75 plus
9.5,
9.5K plus
37,
37K plus
48,
how much?
48.
48.3K plus.
I think that's all.
That's it. Anybody can second Oladipo? And these came from the first calculation. This came from the A, this came from the B, and this came from the C, right? Right? The first one came from the table does not apply. The second one came from A column, B column, C column. We add them all up. Rob, my friend, does it make sense? Did we forget any? Did we get them all? Before? Yeah? Can anybody second? Okay, so now what's the answer?
109.5, 0.6.
1,
109.6.
110. Would you fight with me if I put 110? 110 kW. That's your main demand. Anybody second? 110? Okay, 110. Done. Now we're going to divide it by the voltage to size the cable and size over connection device. Long journey for a very simple thing.
458 remains.
Thank you. So let's take the I. Now we need to find the I. You take the 110K and divide it by 240. And Nick, my friend, what did you come up with?
458 amps.
458 amps. Great. 458 amps. Now I don't want to parallel. I do not want to parallel. I want to carry a work conductor, so I need to size the overconduction device first. Let me go size my overconduction device. So from here, my overcurrent protection device for feeder size. So you're going to take this one, guys. Take the 458. Where do you want to take it? 240.6. What's the next standard? 500. Thank you. 500 amp. Now, Phil, here's the moment of truth. You either size the cables based on the 500, engineers will do that, or contractors to cut cost up to 800, we can size based on what? That size, the actual size. Okay? So, let's go feeders. I want to do the second one is feeder size. Okay, feeder size. I'm going to size it first based on 458 amp. Can you guys give me based on from 310.15 B16? Now, this is where 75 becomes a big deal. 75 degree column. What do we get? One conductor. I know it's big.
700.
700. Thank you. 3 conductors. 700 kcm. Now, some of you would say, Chad, what happened to the rating then neutral? I'm taking a full, because I don't complicate things, we're taking full neutral now. But we can derate the neutral. We can cut the neutral by 0.7. So I'm taking full neutral. Here's the first size. Let's do the engineering way. So engineer size based on what? The overconduction device. So what do you get? Chris, would there be a difference?
900.
900? Wow. That difference? So that would give
75.
under 75 degree. That will give me 900. That not much. Okay. Yeah, default is copper. Anybody can second press on these? So see the difference, Zach? The code allows you to go as low as 700 on this panel, or as high as size based on overconduction device. Now, if you need my judgment, I would size based on the overcam protection device right here. That's what I choose. Why? Because if it's a panel, and this is a 500 amp panel, in the future you can add to this panel, right? So that's a good futuristic thinking, envisioning what's going to happen in the future, right? And I would size based on the overcam protection device. But though by code and fill, you can go as low as 700 kcm, and that's okay. Do you want to parallel? Be my guest, parallel. I just don't want to get into paralleling because we've been running for a long time. Any question, my friends? Any question? I don't want to size the neutral, but the neutral really, in reality, you can take the 700, the 500 here, cut it by 0.7, and size the neutral. Because they're all ranges. Remember, they're all ranges. Or not all of them ranges, no. Not all of them. For the ranges only, you can go pick up, I don't want to over discount, but for ranges only, you can go cut everything that we did by 0.7 and calculate the neutral. Just not complicate things, I pulled full neutral. Any question, guys? So I have a panel of 500 amp feeding all these chunk. Anybody calculated how many devices do we have? How many equipment do we have? 66? 67. So Chris think when you add all these ranges and counters, there were 67 of them in this panel. Imagine 67 times 2, guys. 67 times 2. That will get you 134 space like this one here. 134. So you might not even be able to put them in one panel. 134. The largest that they can make is 84 now. There's no limitation, so you might have to put 2 tops. 84 plus 84. Can you do that one? Do we still need what is 194? Okay, so 2 tops. We need 2 tops to get you there. To fit all this in one. Physically, mechanically, to fit them. Any question, guys? Any question? Nick, are we cool? A good example just goes through a whole thing, put the whole picture together. I usually take it from the feeder point of view, guys, but now we did the branch circuit, which is good, not a big deal, good refresher for a lot of us. That's all I have. Any questions? Go eat.